the Argand plane. Okay, so as we discussed, there are two axes on this real number line and the imaginary number line. And if we actually see, so like imaginary numbers are also like multiple of real numbers and iota. Iota is what? Unit of imaginary numbers. So this is the Argand plane, and we discussed that any point on this Argand plane is a complex number. Okay. So if we take the same, like any point on this quadrant, and let's say that it consists of x and y are its coordinate. That x is the real number part, and y is the imaginary part of the complex number z. So here, if we calculate the distance from of this particular point from the center, then it comes out to be as its magnitude, or we may also call it modulus. Okay, modulus of the complex number. So as we have all studied in our earlier classes, that Pythagoras theorem. So this is hypotenuse, and this distance is the base, and this is the perpendicular, which is like we call this is y. So this is also y, right? Any doubts, anyone? So now please tell me what is the length OP here. The length of P is the magnitude of Z, which is represented in this format. Okay. So please tell me what is the length of OP. Simply just as we know, like the perpendicular is Y and the base is X. So simple Pythagoras theorem. And this is the hypotenuse OP. So what will be its length? Anyone? Okay. So trying my best. Let's say this is a right angle triangle. This is a theta we are considering. And accordingly, this is a perpendicular. This is base, it's hypotenuse. So according to Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square. Is that so? Yes. And here in this case, our hypotenuse is OP. So basically, to find out hypotenuse, we'll bring this square to the right hand side. Clear? Any doubts, anyone? And like, am I properly visible and sorry, audible now? Is the screen and my voice clear?
Yes, sir.
Okay. I think you guys are sleeping. Wait for an hour for that, right? So we were discussing the magnitude or the modulus. Now this will become x square plus y square. Okay. Now as we understand, z is like the length of this particular point from the origin. So we may write it like this, right? So OP length. OP length. Okay. So here, if we see, there was origin O and a point P, X, Y, and we were finding out the modulus of Z, modulus Z minus 0, because it was origin. So this is what? The distance OP, right? The distance OP. Now, if we take any 2 points, let's say Z1 and Z2, having x2, y2 as coordinates and x1, y1 as coordinates. Now if we find out the length between these two, so using the distance formula, x2 minus x square plus y2 minus y1 whole square. Now the distance between these two, let's say this is a, this is b. The distance between these two, ab, is z2 minus z1. Okay, any doubts, anyone?
No, sir.
Yeah, if we find the length of the given particular point in the Argand plane, then this length is the modulus when we find out with respect to origin. Clear? With respect to origin, so that becomes the modulus of that particular complex number. Okay, so let me ask some questions. 3 plus 4 iota. Now please tell me the find modulus of following complex numbers. Please calculate. Anyone? What is the modulus of this? Is anyone's brain working here? What was x? X was simply the real part of complex number. What is y? The coefficient of iota, simple, the imaginary part. So 3 square plus 4 square, that becomes 9 plus 16, whole square root, 16 square root becomes 4. Is that correct? No, no, no. 9 plus 16, that becomes 25. The square root of 25 is 5. Right? Do you agree?
9 plus. Mm,
That becomes 25, right?
yes, sir.
Now the modulus of this also, 3 square becomes 9, minus 4 square again becomes, so it will all be the same. So its modulus will also be the same. Its modulus will also be the same. So from here we can draw a conclusion. The modulus of complex number, its conjugate. Conjugate is the complex number when the coefficients, or the coefficient of the, basically the imaginary part of the real number, sorry, the imaginary part of the complex number, sign is changed. Simple. And its magnitude is also equal to this. Clear? Any doubts?
No, sir.
Great. So let's go back and understand what more properties of modulus are. So as you know, that modulus is a length, right? As we know, modulus of any complex number or magnitude of any complex number is length. So length can never be negative. It can be 0. So it's the case. Okay. If z is a complex number, so I'm not going to write it again and again that z is a complex number here. So now please tell me, is 1 a complex number? Anyone?
Yes, sir.
Very good. 1 is a complex number because it is there on the Argand plane. And simply the definition of complex number is x plus y iota, where x and y are real numbers. Where, like, we know 1 is a real number. So great. 1 is a complex number for sure. Okay. And if we find out the, like, when the modulus of z becomes 0, so as we know, if, like, say a complex number is this, so for its modulus to be 0, square root of x square plus y square has to be 0. So squaring on both sides, x square plus y square has to be 0. Now we know the square of anything is positive. So the sum of two positive things are only going to be 0 when they both are 0, right? Only x has to be 0 and y has to be 0 to make this condition satisfied. Otherwise, there are no any real values for x and y to make this particular equation 0 other than 0. So as we know, in complex number, x and y are real numbers. So for this to happen here, x and y has to be 0. Okay, so if the modulus of any complex number is 0, that means the complex number is 0 plus 0 iota. Any doubts? Any thoughts?
No, sir.
Hmm. So now let's discuss about. So now it's very much clear to us that let me. Okay, let's let it stay here. Real part of complex number and imaginary part of complex number. Okay, so it's like saying 3 plus 4 iota. So 3, the real part of complex number, lies in between. What is its modulus is 5, we earlier know. So minus 5 and plus 5. Yes, it stays true. Checking for imaginary part, minus 5 greater than minus 5. Yes. Less than plus 5. Yes. Stays true here also. This is the property. Okay. It says that the real part of the complex number will lie in the range of minus plus uh, domain. So it's similar to saying that x and y will lie in this range. And this is true everywhere where x and y are real number. It's true forever. Forever it's true. Because we know x square and y square are two positive quantities. And x is getting squared and plus it's getting added to another number which is a positive quantity. So, and even if the square like the square root is taken, but still it's greater than x, right? If it's greater than x, and then definitely it's going to be more than x. I hope I'm like, let me give you an understanding of this point. So if we take y0 here, then what it becomes? X square plus 0 square root, and it becomes x only, right? So the equality exists here. If we take y is equals to minus 1 and y is equals to plus 1, let's check what happens, what is happening here. So if we take y is equals to minus of 1, so what it will become? X square plus 1 square root. X square plus 1 square root again, because minus 1 square is plus 1 only. So x square, like if even if 1 was not here, then it has to be equal to x, not less than that. And if something is getting added, So it's definitely becoming more, not less. So that's how we can make a sense. And same goes for the other side. It's just that the sign is reversed, so the inequality will be reversed also. Understood?
Yes, sir.
Yeah. So, and where don't forget that x and y are real numbers here. Okay, this is the property. Coming to the next property, one that we have already discussed, where it is, where is it? Work plus, yes, this is also a property. Let's copy paste. Okay, let's move ahead now. Discussing the next property. And now, what is this? Please tell me. Anyone?
No.
Hmm.
Yes, sir.
It is a conjugate of complex number. Okay. Z is what? X plus iota y. Z conjugate is x minus iota y. Now it is, let's solve for the left hand side. Let's multiply the both. X into x becomes x square. This into this becomes xy into iota. This becomes, this into this becomes x plus xy plus uh, plus xy into iota minus 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 y square and into iota square. Iota square will make it positive. This cancel this. So this is x square plus y square. Now x square plus y square, we know x square plus y square square root is modulus of z. We take the square on both sides of this equation. This will become modulus of z square. So LHS is equals to RHS. Any doubts?
No, sir.
Great. So the fifth property is very simple, that z1 into z2 okay, the modulus of z1 z2 is equals to the modulus of z1 into z2, where z1 z2 are complex numbers, and it's the same for uh, division also. It's just that we have to make sure that z2 is not a 0. Writing any like complex number is equaling to 0, that means the complex number has not to be 0. Clear? Any doubts?
No doubt, sir.
It's similar to triangle inequality. As we know, it's all the distances. So if two positive quantity are getting added, so definitely they are going to be more than the sum of both of these two, because in this there is a contingency where one of the complex number may become negative. So if that happens, definitely it's going to be less than the sum of other two, like both of these two quantities, because now we are taking the modulus of these two, so they will definitely, both of them will be positive. But if one of the complex number becomes negative here, then there will be this particular inequality staying true. Okay. Any doubts?
No, sir.
Okay, so this is also called triangle inequality. It is quite important in JEE. Eighth, it's the opposite for when we take the negative between these two positive quantities, because here subtraction is happening for sure on the right hand side and addition is happening for sure on the right hand side in the seventh property. That's why they're written down like this. Any doubts?
No, sir.
Okay. Shall we take some example?
Yes, sir.
Danish, are you present? Anyone else? Rishi? सब proxy मार रहे हैं. Okay. So taking example of this first. So letting z1, as this is a complex number, so we can take simply any real number. Z2 is minus of 2. Okay, so z1 plus z2 here is 3 minus 2, that is 1 on the left hand side. So 1's modulus is 1 only. Z1 is 3 plus 2 because the modulus is there. So definitely it's going to be plus. Why have I written only 3 and 2 directly? Let's try to find out its modulus. 9 square plus 0 square. So 9 square is, sorry, 3 square plus 0. So it becomes 3 only. 2 square minus 2 square plus 0. So minus 2 square is 4. 4's square root is 2. Okay. So we take 3 plus 2. So it's definitely more than 5. The first property is true. Any doubts? Any doubts?
No, sir.
Let's take the second properties example. First, summing. We have already seen the sum. That is 5, and 5 has to be greater than the difference between these two. 3 minus 2. The modulus of 3 is 3. The modulus of 2 is 2. There's a negative sign in between. So 5 is greater than 1 for sure. Let's take for the difference. So 3 minus 2 is 1. Should be greater than z1 minus z2. That is 3 minus 2. So 1 is greater than equal to 1. That is also true because equality is existing here. Any doubts?
No, sir.
Great. So this is why it is staying 2. And this is triangle inequality where numbers you can also consider the place of z1 and z2, a and b being the two lengths of any triangle. Okay, so the next property is, if we take any complex number and if we like raise its power to n, then find its the modulus. So it is equivalent to saying and finding out the modulus of z first and raising its power after that. So it's like, let's take x is equals to 1 plus um 1, there's no, so let's take 2 plus 4 and 3 out anyways. Its modulus is what? 4 plus 9 square root becomes 30 square. So if we square it, 2 plus 3 iota square. So 4 plus 3 iota square, 9 iota square. Iota square becomes negative, plus 2, 4 into 3, 12 iota. It's minus 5 plus 12 iota. So let's find out the square root of z square. It's 25 plus 144. That is 169. That is 13. Right. Now let's fine, and let's square it. That is 13 itself. So from the observation, we can state that the modulus square is equivalent to finding square, the modulus of the square of complex number. Clear?
Yes, sir.
Clear? Yeah. So go on to the next property. Z1 minus Z2. That's similar. That's the same property which we were discussing about. Let's go back. So from here we can say that Z1 plus Z2 modulus is less than equal to modulus of Z1 plus modulus of Z2, which is, if we like take the positive sign here, which is greater than Z1 minus Z2. Clear? Are you able to understand that how have I written so? Like from the conclusion of both of these two?
Yes, sir.
Great. Let's now move to the property number 11 if it is present. Now this speaks about something interesting. This is the conjugate, Z2's conjugate. And this will be the answer when there will be plus sign in between these two complex numbers. But now here it is a negative sign when there will be Z1 minus Z2 complex numbers modular square. So, and it can be like represented in multiple formats. One that we can also write it like plus minus Z1, Z2 conjugate plus Z1 conjugate into Z2. So that's, and remember the significance of the small brackets here. You don't remember them, then it will change the game. Okay. Now, should I give any example? I should, right? Hello,
Yes, sir.
like Sadhguru. How Sadhguru says hello. Like, let's say Z1 is 2 plus 3 iota. Let's say Z2 is 4 minus iota. Find out Z1 plus Z2. There comes 4 plus 2, 6 minus 2 iota. And Z1 plus Z2 is this. Z1 minus Z2 is 2 minus 4. There is minus 2 plus 3 plus that becomes plus 4 iota. Z1 plus Z2 and Z1 minus Z2. Let's find out the modulus of this complex number. This is square root of 36 plus 4 square root of 40. If we square it on both sides, so this square will be vanished. Let's find out the square, the modulus of this. 4 plus 16, which will become 20 after squaring. Okay. So we have find it out the left hand side of the both. Now let's try to solve the right hand side. Any doubts, anyone till now?
No, sir.
So this is what LHS. Let's find out RHS. Z1's modulus is Z1 modulus square is 4 plus 9, that is 30. And Z2's modulus square is 16 plus 1, that is 17. So right hand side says 16 plus 17 plus minus 2 into real part. Now we have to find out the Z1 into Z2 thing. So Z1 is 2 plus 3 iota. Z2 conjugate is 4 plus iota. Now 2 into 4 becomes 8. 2 plus iota plus 2 iota plus 12 iota plus 3 minus 3 because of iota square. 5 plus 14 iota. 5 plus 14 iota. Please write 5 plus 4 iota. Oh, sorry, 14 iota. So this is Z1 into Z2. This is Z1 into Z2 conjugate. Now we have to take the real part of this. So the real part of this is what? 5. So plus minus 2 into 5. Great. 16 plus 17 becomes what? 30 and 3. 33 plus minus 10. So if we are finding out, okay, I guess we are missing on something. Let's go back then. 2 plus 3 iota, 4 minus iota, plus 6 plus 2 iota. Okay. So there, plus should be there here, right? 2 plus 4 becomes 6. 3 minus 1 becomes plus 2. So the modulus of the same will remain the same. 16 plus 4, sorry, 36 plus 4, 40 only. 2 minus of 4 minus 2. 3 plus 3 minus of minus 1, 4. So that becomes 4 plus 16, 20. Right, that's right, that's right. Now let's discuss about Z1 into Z2's conjugate. 2 plus 3 iota into 4 plus iota. 2 into 4 becomes 8 plus 2 iota plus 12 iota minus of 3. 5 plus 14 iota. The real part of this is 5. Okay. Into 2. 16 plus 17 becomes 6, 7. 6, 7 becomes, yeah, 13. That's right, I guess. So 43, 23 should be the answer, but it's not the case. I think we are missing on like 3 numbers. Okay. So the modulus of this is 4 plus 9, right? 4 its square plus 9 square, and its square is 16 plus 1. That is, um, can you find out what mistake I'm doing?
So,
No, no, let me recalculate everything. Only let's don't change the complex numbers. Otherwise the question will be changed. 2 plus 3 iota and 4 minus iota. Okay. Okay, sorry. And the modulus of z1 is 4 plus square of 3 becomes 9, square root of 30. Modulus of z2 becomes 16, 4 square plus 1, that's square root of 70. Now z1 plus z2 becomes 2 plus 4, 6. 3 minus 2 becomes 6 plus 2 iota. I guess we were doing a mistake here. Z1 minus Z2 becomes now 2 minus 4, that is minus of 2, plus 3 minus of minus 1, that becomes 2 plus 4 iota. Z1 minus Z2's modulus is, let's find out its square directly. 4 plus 16, which is 20. 4 plus 16, okay. Z1 plus Z2's modulus whole square is 36 plus 4. That should be 40. 36 plus 4. That should be 40. Okay, cool. Yes. I got the mistake that we were doing earlier. Anyways, let me write the formula. What was the formula? Z1 plus Z2 whole modulus plus minus Z1 modulus square plus Z2 modulus square plus minus 2 into real part of Z1 to Z2's conjugate. Okay. Or even sometimes we, और यहाँ पे लिख देता हूँ, for the substitute of the third term we can also find out the z1 z2 conjugate plus z1 conjugate and into z2. Doubts? So we will going to first verify the first formula. So I'm going to write in the orange color now. So for the left hand side, for the positive part, it is 40. Now z1 square is 13 plus 17 plus minus 2 into real part of z1 into z2. Basically, what is z1 into z2? Is 2 plus 3 iota into 4 plus iota. That becomes 8 plus 2 iota plus 12 iota minus of 5. Minus of 3 into iota square makes it minus 3. That is 5 plus 14 iota. The real part of this is 5. Now, you are doing a mistake here, a simple normal mistake. We were writing 16 here mistakenly. 13 plus 17 becomes 30 plus minus 10. Now, in the case of positive and for the case of negative, it has to be 20. So let's check. For the case of positive, it is 40. For the case of negative, it is 20. So this particular formula we have verified. Any doubts? Anyone?
No, sir.
So Z1 into Z2 conjugate was 5 plus 14 iota. Now let's find out for the Z1 conjugate into Z2. So Z1 conjugate is basically 2 minus 3 iota and Z2 is 4 minus iota. So 2 into 4, 8 minus 2 iota minus 12 iota plus 3 iota square, that makes it iota square makes it negative. Okay, 8 minus 3 makes it 5 minus 14 iota. So plusing this and this will give us 10. So it will like this was coming as 10. This is also now coming as 10. So you may understand the answer is going to remain the same because this is 13. This is 70. So 13, 17 is 30. And 30 plus minus 10 will give us 40 and 20. Any doubts, anyone? Clear everything?
Yes, sir.
Clear?
Yes, sir.
Yeah. So, okay. Let's go ahead now and discuss the remaining properties. Now, it may also happen sometimes that this particular term becomes 0. This particular term becomes 0. And when it will become 0, so our remaining answer will be this only. Okay. And when this will become 0, we'll discuss it later. when we will discuss about arguments more. Okay. Okay, so what I just told you, that sometimes z1 plus z2 whole or the modulus of whole square may equal to this. Okay, when I'm going to explain it later. What is this? Okay, there's another property, z1 plus z2 modulus whole square plus z1 minus z2 modulus whole square is equals to 2 into modulus of z1 square plus modulus of z2 square. This is simple another derivation of this property only. This property only when we'll like let me write it properly elaboratively. What is the formula of this? Modulus of z1 whole square plus modulus of z2 square plus uh, plus 2 into real part of z1 and the conjugate of z2. Yeah, right. What is the formula of this? Plus modulus of z1 square plus modulus of z2 square minus this time 2 to real part of z1 into z2's conjugate. This and this will get cancelled. What will be left is the right hand side. Clear? Any doubts, anyone?
No, sir.
Okay. So let's discuss an example and